Let's compare the NMR spectrum of pure ethanol with ethanol that is contaminated with acid. And you can see in both of these cases, there are three different peaks because there are three different types of protons. Okay, this is going to be the methyl protons. And the methylene protons are actually exhibiting as a multiplet, and that's because of the combined effect of the three methyl hydrogens and the hydrogen from the hydroxyl group. And here is our hydroxyl group, which actually is split as a triplet. But when you take the NMR spectrum of ethanol that is contaminated with tiny amount of acid, you can see that this methylene proton is actually split as a quartet, and the hydroxide proton actually exhibit as a singlet. And the reason for this is because they are actually going to experience the proton exchange effect. The proton exchange happens either by acid or base. Here is the acid catalyst proton exchange mechanism that is shown here, where you can see that this hydrogen is being replaced by this hydrogen from the acid. Okay, and the chemical shift of these hydrogens is actually going to depend on the extent of the hydrogen bonding. Okay, and because of which the hydroxide protons can actually show anywhere between like 4.5 to even 9, and they are generally broad. So instead of appearing as a very sharp singlet, they are going to appear something like this. And one best way to identify the hydroxide protons is after you prepare the sample, if you're going to add like 1 or 2 drops of D2O, then they're going to get the hydroxide, the hydrogen from the hydroxide ion is actually going to get replaced by the deuterium, and therefore this signal should disappear. Okay, that's the best way to identify the hydroxide protons in an NMR spectrum. Resolution of a Hmr spectrum. Here are two different spectrum which has been produced by two different spectrometers operating at two different operating frequencies. This spectrum was received in a spectrometer which operates at 60 megahertz, and this is received from 300 megahertz operating frequency spectrometer. And you can see that the peaks in the 300 megahertz spectrometer has been resolved to the extent where you can see the actual splitting pattern in the compound. Whereas here, many of the peaks are overlapped, leading to poor resolution. And nowadays we have NMR spectrometers which ranges even close to 1020 megahertz, in which case you will be able to see better resolution of the different peaks.